lecture number 6, and we're going to go into some of the procedures that are used in 4G LTE. So let's start off with the USIM concept. Now, when we moved from 2G to 3G, there was a change in the way we dealt with the SIM card technology. Okay, in the GSM, when we talked about the SIM, it was a physical card, the card that you can touch. Whereas when we moved to 3G and technologies beyond 3G, the physical card is referred to as UICC, where UICC stands for Universal Integrated Circuit Card. Now, on the UICC, on that particular card, you can run a number of applications. You can run a 3G application, which is the USIM. You can have a 2G application. You can have an IMS application. So all of these are now applications that run on a card. So on one particular 3G and beyond card, you can have number of different applications. So that's quite useful, because when you are a 4G subscriber and you move towards the edge of a 4G cell and you have to move to a 3G network, or sometimes even to a 2G network, if all the information that is needed for you to communicate is on that card, then it becomes much more easier. So that's why the concept of SIM card has changed, and now there are applications that run on a card. So you can have a SIM application, a USIM application, an iSIM application, and all of them are used for different purposes. Obviously, the SIM and the USIM. So let's take the example. There's a person here, Alice, and there's a person here, John. They were on a 3G network and they want to update to 4G because they've heard so many good things about it. So obviously, the first thing they need to do is they have to purchase a user device that is capable of supporting OFDMA and MIMO and related 4G technologies, because a 3G mobile will not work on a 4G network. So once they buy the handset, the next thing they need to do is to get a new IMSI, MSISDN, that is the dial number. So even when you move from 2G to 3G, most of you might have kept your same number that people dial you on, because number that people dial you on is something that is very important, and you don't want to be changing that. Okay, so a lot of people want to maintain the same mobile dial number, but an IMSI is a number that is hidden. It's only used internally within the network. So most operators nowadays give a new IMSI, but they keep their old MSISDN number. Okay. Now, it's also preferable to get a new card, because even though you might have had a UICC from a 3G subscription, there are some new features that are there in the 4G card which were not there in the 3G card. So because of that, most operators and most vendors and most shops selling 4G services will say it's better for you to get a new UICC card, and which will obviously have your new IMSI number. And so you get your new 4G USIM card, and into that the MSISDN number is put into it. Now these numbers here that you see for Alice and for John are all numbers with a number code in France, because these slides are from Alcatel-Lucent, so they were developed in France. So the next thing is the need for independence between UE and IMSI. Okay, the UE is hosting the UICC card, and the IMSI is recorded into the USIM card. Now, the IMSI, as I told you, is a number that is you've already seen in your 3G course or your 2G course before, or some of you for whom this is new. Just to let you know that IMSI stands for International Mobile Subscriber Identity. It's a unique number that is kept only at two places in the network. The first place is on the SIM card, and the second place is in the HLR. Okay, it's not kept anywhere in the network, and it's also the use of the IMSI is always minimized, because if somebody knows your IMSI, your service is compromised. So the IMSI is again a very important number, highly secure number that is rarely used except in specific circumstances. Like the first time you switch on your mobile, when you go to a mobile shop, you buy a new mobile and maybe you get a new IMSI, a new SIM card, and you put it into your mobile. The first time you switch it on, obviously then the network doesn't know you, so you have to transmit your IMSI. But thereafter, the transmission of IMSI across the air interface is minimized. Okay, so if you go now and have a look at what sort of information is kept in the SIM card, there's tons and tons of information. You'll be surprised at the amount of information that a USIM application will hold. But the basic information can be classified into three types. The first type is called static data, data that does not change. For example, IMSI. IMSI is a number that it doesn't change. Okay. Then you also have some security keys. There's a key called a ciphering key, which is used for confidentiality purpose. That means everything that is transmitted across the interface is ciphered with the ciphering key. And then you also have something called an integrity key. Integrity key is, in security, you have something called man-in-the-middle attack. Okay, somebody in between can change the contents of a message. Now you want to make sure that the integrity of a message has not been compromised. So we have something called the integrity key that is used for that. Now we'll have a look at these a little bit later. Okay, so that's another piece of information, static information that's never changed. Again, both the IMSI, the ciphering key, the integrity key are only stored in the HLR and in the SIM or the USIM application. Again, because of the importance they have for the security of your subscriber. You may also have forbidden P elements. Okay, so there are some operators that might not want their UE to roam on certain P elements. Okay, so they might set them as forbidden P elements. So that means you're never allowed to roam on that particular network. Okay, for example, in the case of in Australia, for example, Optus might have a arrangement with Singtel in Singapore. So when you land in Singapore airport, they don't want you to go on to any of the Singapore network like Star or one of the other networks. So they might put those as forbidden P elements, so that when you switch on your mobile and you land at Singapore airport, you don't go into the forbidden P elements. You only go into the authorized P elements. P element stands for Public LAN Mobile Network. There's other type of information that is referred to as dynamic information. Dynamic information is information that can change. Okay, so for example, location area identity. As you move from cell to cell, sometimes you may cross from one location area into another location area. A location area is a group of cells. Okay, so you may change location area information. So in that case, the SIM card needs to be updated to say that you've now changed from location area XYZ to location area ABC, for example. The other aspect that might have to change is something called TIMSI. Okay, now TIMSI stands for Temporary Mobile Subscriber Identity. That's a temporary number. Okay, now because the IMSI is highly secure number, we rarely transmit that across the interface unless it's really necessary. But at all other times, we allocate a temporary mobile subscriber identity, a temporary number which can be used for exchange, and that temporary number might have a certain lifetime, or it might have a certain geographical limitation. So when you go beyond a certain geographical area, you may have to obtain a new TIMSI. So it's less likely, it's all probability, it's less likely that you will be compromised security-wise if you're given a temporary mobile subscriber identity. Okay. Now, we will see later on that in 4G, we are going to allocate a number called GUTI. which stands for you, GUTI stands for Globally Unique Temporary Identifier. Okay. Now this is the equivalent of TIMSI. Remember, TIMSI comes from the GSM era. Okay. And then when we moved to GPRS, we had concept of PTIMSI or packet TIMSI. Now when we move to 4G, we are going to use an identifier that is referred to as Globally Unique Temporary Identifier, or GUTI. Okay, and we also have information related to tracking area identity. So I think we mentioned in the first class or second class that we have this concept of tracking area in 3G, and when we change from one tracking area to another area. The tracking area is remember in GSM we talked about location areas, in GPRS we talked about routing areas, in 4G we talk about tracking areas. So each tracking area has an identity with it, a number associated with it, and that is another piece of dynamic information that is kept stored in the SIM card. So when you change from one tracking area to another tracking area, that number has to be updated. There are also algorithms that have to be stored in SIM, okay, and these are the ones that are referred to as EPS, authentication and key agreement procedures, which we'll have a look at a little bit later. So on the next slide, a couple of things. I've just put this slide here for those who may have not come across these terms before. Okay, in 2G and 3G as well as in 4G, we have a number of identifiers that are used for different things. So you have MSIN, which stands for Mobile Subscriber Identification Number. Okay, and then you have MCC, which is a country code, and for example for Australia, now this is different from the country code that you dial. Okay, this is a country code that is associated with a network identifier. So for example, Australia, the MCC is 5505. MNC is a network identifier, so each network operator has a different number. Telstra is 01, Optus is 02, and so forth. IMSI is the number that I talked to you about, the very confidential number. Now that's made up of three parts. It's made up of the MCC, the MNC, and the MSIN. Okay. So the IMSI contains the country from which this particular subscriber is from and the network it is in, as well as the number that identifies the subscriber. Now this IMSI number is completely different from the dial number. Okay, the dial number is MSISDN. Okay, the IMSI number is only stored in two places in the network, the SIM card and the HLR, and it is never transmitted. The transmission across the air interface is minimized. Okay. Now the reason we put the MCC and MNC into the IMSI is sometimes you may be in another part of the world, okay, and you may switch on your mobile and you may have to transmit your IMSI. So the network on which you're roaming needs to be able to send that request to your home network. So it needs to know how to identify your home network, and that's why these numbers form part of the IMSI. Now another number, remember we talked in previous classes that the MME, the Mobility Management Entity, is the one that is responsible for all of the signaling that occurs between the UE and other network elements. Okay, so the MME is very much similar to the VLR in GSM. Not exactly the same, but a little bit similarity exists between the MME and the VLR. So the MME, just like the VLR allocates TIMSI to a UE, to a mobile subscriber, the MME allocates something called a MTIMSI, okay, to a mobile subscriber. And you also have something called STIMSI, which is just the number of the MME plus the mobile TIMSI that was allocated by the MME. So it combines the two. Okay, a little bit clarification will be coming up in the next couple of slides. Now, we also have to identify, we need to have globally unique numbers for MMEs, because when you roam on some other network in a different part of the world, your home MME needs to be contacted. Okay, so just as we have, we also add the MCC and MMC to globally identify a MME. Okay, so there's so each MME has a code, a number, an 8-bit code, and then a group of MMEs also have a code called a MME group identity. Now, if you put the MCC, the MNC, and the group identity plus the number of the MME, all of these together, it gives a globally unique MME identity. And these identifiers have been set up for that purpose. So I talked to you about the GUTI earlier. I said in 4G we start using something called GUTI. So a GUTI is a number that uniquely identifies the MME and the subscriber within the MME. Okay, so it has two parts to it. Probably the next slide here has a diagram that shows it a little bit better. So effectively what we have, if you look at the new temporary identifier that is going to be allocated to a UE, the GUTI number is made up of a country code, a network code, an MME group identifier, an MME identifier, and a 32-bit number that is allocated by the MME. So altogether, it's quite a large number. You have almost a 76 to 80-bit number, which is quite a large number to be transmitting. So sometimes when you're working within your home network, we just use STIMZ, because this part is all that is needed. If you look at it, this part is all that is needed this part here is all that is needed to uniquely identify a subscriber within your home network. But when you roam, you need the complete identity. The next thing that we're going to have a look at is the HSS. Okay, now the HSS is sort of an evolution of the HLR from the 4G network. Okay, so HSS stands for Home Subscriber Server. And what is it? It's essentially a group of databases, and it is made up of the HLR which we had in our 3G network, the authentication center, which is primarily used for generating authentication vectors. Then it also has the IMS database in case you have an IMS network allowing subscribers to make VoIP calls. Then you also have the EIR, and that's an optional feature. EIR stands for Equipment Identity Register, that stores information about handsets. Then you have MNP, mobile number portability. Okay, just a spelling error, optional, should be single N, not double N. Okay, and other features. Okay, now what sort of information? Now there's a hell of a lot of stuff that is kept in the there's a lot of stuff that's kept in the databases. Okay, some of the information is static, some of the information is dynamic. So we've just got some of the important ones here. So we've already talked about the MS-ISDN, which is the dial number. You also want to have the IP address of the MME that's currently serving the mobile subscriber. Okay, so at any point in time, for example, in the case that you have an incoming call coming into a network, the first thing you want to do is you want to find out which MME is serving a particular subscriber. So the network has the capability of going to the HLR database and finding out the MME, the IP address of the MME that is currently serving a particular mobile subscriber, and then sending a request to that MME to set up a call. Okay, so that's why we need to store in the HLR database, we need to store the MME that is currently serving a mobile subscriber, and so forth. So there's a whole lot of other information that is stored there, and that's given in the table. Now, you also have other information. A subscriber can connect to many different PDNs, packet data networks. Okay, so for each PDN that it can connect to, we need to keep some information about it. So what type of PDN is it? Is it IP version 4 or IP version 6, or does it support both? What's the access point name of this particular PDN, and so forth. So there's a whole lot of information that we need to store about every packet data network or PDN that a UE can connect to. Okay, now last week we talked a little bit about the quality of service that an EPS bearer can have. Okay, so we said that each bearer that's in each EPS bearer can either be GBR, guaranteed bit rate, or non-guaranteed bit rate, and associated with each one of them is a class identifier, a QCI, and also an allocation and retention priority. Now, when you specify a external gateway, you normally specify something called an access point name. Now, some of these terms will be new to some of you who don't have sufficient background in this area, but an access point name is a name that you specify when you want to connect to a network. For example, when we want to do have a look at our Gmail account or our Yahoo account, we normally go on a web browser and we type yahoo.com. Okay, we are specifying a domain name. The reason we specify a domain name is because humans can remember names far better than numbers, and so when we specify this particular name, this name gets translated into an IP address by a DNS server in the network. So the similar concept is used in mobile networks as well. Instead of getting people to specify the IP address of an external network to which they want to connect to, they usually specify something called an access point name. Okay, and the access point name is translated to an IP address by a DNS within the network, or it could also be hard coded. Okay, so basically, whenever you do an attach process, so the question you might ask is, if all this information is sitting in the HLR, how does the MME get it? Because MME is the mobility management entity is the one that is going to process all the subscribers' requests. So what happens is, whenever you attach to the network, and we talked a little bit about attach last week, and we're going to look at it more detail today. Whenever you do an attach, the message gets sent to the MME, and the MME goes to the HLR database or HSS database, and it downloads all the subscriber data into its own database. And once it has this information in its local database, then it can start providing services to the subscriber based on this information. Now, the reason we have this data download procedure, now this is not new in 4G. It was there previously in almost all of from 2G onwards. Okay, and once you do this once, as long as the subscriber is within your area, you hold that information. And once the subscriber leaves your area and moves to another area, you sort of get rid of the information. Everything that's shown on the blue dotted line represent the control plane, and the data plane is the plane that goes in red here. eNodeB, serving gateway, packet gateway, and out to the PDN. Okay, and apart from this, we also have the HSS. Now, we also talked a little bit about this concept of pools. So, we tend to have this concept, instead of having individual eNodeBs and individual MMEs and individual serving gateways, we sort of put them in pools. So, we have a pool of MME, or a pool of serving gateway, or a pool of pool of tracking areas. Now, why do we do this? Okay, that's a very important question. Why should we use this idea of pools? Well, in one way, it sort of improves the service availability, because maybe one MME could be down and the service could be shifted to another MME within the pool. And also, when a UE moves from one area to another area, we don't have to be constantly changing MMEs and serving gateways and so forth. So, by having this idea of a pool areas, it helps to do that. So, this is something sort of new in a 4G network. So when we talk about a pool area, we say one or more tracking areas served by one or more MMEs or serving gateway pools. Okay, so these when we specify an access point name, specifying which external network we want to connect to, we get an IP address. Okay, and every time you deregister and register again, you may be allocated a new IP address, because you may have a group of IP address allocated with a particular access point name. So you might be given different IP addresses at that point in time. Okay, we move on. Okay, what's in the next two slides for me is something that we've covered before in the last couple of lectures, and I'm moving on to UE initial attach. So what happens here? Network attachment is essentially a procedure by which a UE registers with a network so it's able to get packet switch services. There are three types of attaches that are important. The first attach is called IMSI attach. The very first time that you switch on your mobile, or in the case of roaming and you move to a new network, you might do an IMSI attach. But otherwise, you do the attach with the GUTI. Okay, and we talked about the GUTI earlier. This is the temporary identifier that sort of identifies a subscriber. So IMSI attach first time, thereafter you do attach with GUTI, and then you also have this third attach for something called UMTS circuit switch fallback. Okay, so a lot of operators are implementing this idea, the idea that when you want to make a call, you fall back to a circuit switch network in a UMTS network. And this is referred to as a combined EPS IMSI attach. The three types of attach. that can take place. Now, in all of these attaches, there are three procedures. One is a request message that usually comes from the UE, but it can also come from the network. In the case of, in response to an attach request, you get an attach accept, and you end everything with an attach complete. So it's a three-way handshake: request, accept, complete. Sometimes an attach can be rejected. The network might not have sufficient resources to accept an attach, so it might reject that. So you get an attach reject being sent. So for example, if somebody asks you what sort of things have to take place in the network when an attach take place, you should be able to list the important steps. You should know that, well, when you first power on your UE, first thing that has to be established is an RRC connection, and we talked about RRC connection last week. Once an RRC connection is established, then the UE gets authenticated. Okay, and once the UE is authenticated, an IP address is assigned, but it's not delivered because a bearer has not been set up yet. And thereafter, the bearers are set up. The EPC bearers, the bearers within the EPC network. And the next thing is the radio bearers are set up. And once the radio bearer is set up, the UE will receive the IP address, and now it can access the PDA. Now, these are the basic steps, but if you want to know in detail what's happening, the next couple of diagrams. Now, I want you to make a note here. Now, on some of these slides, I put not examinable. Okay? That means I'm not going to ask you in the exam to draw these timing diagrams. But these timing diagrams are provided purely for your own self-knowledge. Okay? So, you can sort of try and understand how messages are exchanged between the UE, the eNode B, the MME, the S gateway, P gateway, and so forth, and the HSS. Okay, so the next set of diagrams explain in detail how the IMSI attach procedure is done. Okay, and at the end of it, you can see the IP address is assigned to the UE. Now we go further. Just a bit of recap. We talked about this earlier, but this number GUTI is the important one. As a temporary identifier to identify a mobile subscriber. There are three types of attaches. The first attach is when you buy your 4G phone with a new SIM card and you switch it on for the first time, and that's called a first network attachment. And this is the one in which the IMSI is transmitted across. Okay, because the network does not know you. It has never heard from you before. Okay, so when the IMSI goes across, the MME has to go to the HLR and pull down your information, all the information about you, which is stored in the HSS database, has to be pulled down to the MME, and thereafter the MME can start setting up a session for you, okay, and essentially set up a pipe for you from the UE through the eNode B, through the serving gateway, through the packet gateway to the PDN. Okay, so on the next couple of slides, we have the detailed timing diagrams. Again, I ask you to just go through it and sort of familiarize yourself, but I don't expect you to know this. So all these timing diagrams, just put a note there, it's not examinable. Okay, so two things that have to take place when you do a network attach. So remember, two things have to be selected. One is the serving gateway and the other one is the packet gateway. Both of these have to be selected. Yeah, okay. For a subscriber who's already been on the network. So what do you think is the difference between network attached based on IMSI and one of the important difference between network attached based on IMSI and network attached based on GUTI? The information is already present in MME because MME has already gone to the database and downloaded all the information. And what's the second important thing? So you already know which MME I should send the request to. When you do IMSI attach, that IMSI attach does not tell you which MME. In fact, the MME may have never even served the subscriber because the subscriber is a sort of a new subscriber. So in the IMSI attach, you have to go and select the eNodeB has to go and select an MME. Whereas in the case of network attach that's based on GUTI, that information is already known. So the eNodeB can, send the request off to the appropriate MME because it can extract the MME address from the GUTI information. Okay? Yeah. Or in the case where you get into a plane, you switch off your mobile, and when you land, say somewhere in Melbourne, you switch on your mobile there. Okay, so now you've changed MME. You're in a different MME. So again, what happens is eNodeB will recognize that your GUTI, the MME associated with your GUTI is not associated with the local pool of MMEs. So it will again select an MME and send it to it. Now the MME, the new MME, that's why we use the term new MME and old MME. The new MME goes to the old MME and it extracts the information from the old MME database, saves it in the new MME, and optionally it has a mechanisms to do another authentication. Again, some of these settings can be, and in this case it's also possible that you've not only changed MME, but you may also have changed your serving gateway. So again, you need to set up a new serving gateway, but the P gateway, the packet gateway that you may be using might be the same one, okay, or it may be a different one. So the signaling that is needed for this particular case where there's a change in MME is shown in on 59 and 60. So again, I don't expect you to know things at this level of detail, but I expect you to know the difference. Okay, the important thing is always the difference. What is the difference between the situation where the MME does not change and the MME changes? So again, all of these timing diagrams, not examinable. I hope you're making a note of it, because if you have to study all. Okay, now there is an important point on slide 61 that I want to go through. Okay, so I'm going to read through this with you. An eNodeB may connect to several MMEs. So it uses a MME selection mechanism to select the MME that should serve a UE. Once a UE is attached to one MME, it continues to serve the UE while the UE stays in the coverage area of the pool. Okay, now there is a mechanism called MME SGW relocation. So MME SG relocation is needed when the UE moves from one area to another served by another service pool. In that case, eNodeB in border areas can have S1 connectivity to several neighboring. Okay, so this is what they mean by when you have tracking areas that are in border areas. Okay, when an eNodeB is in border areas, it can have connectivity to several neighboring pools. Okay, so if you look at this particular tracking area here, it's in the border area of this MME pool and this MME pool, and it has connected with it to both. Okay, now basically this mechanism is going to assist in the process of MME serving gateway relocation. Similar to what I showed you earlier, we always make sure that there is some overlap between MME pool areas. Okay, now just as we have load balancing in P gateways, we also have load balancing within MME. Okay, so the MME load balancing functionality, that's on slide 61, the last point that is there says that the MME load balancing functionality is used to load balance the UE on MME within a MME pool. Okay, and it uses something called weight factors. So the MME load rebalancing moves UEs from a MME to another MME within the pool. Okay, so again, this is a mechanism that is done by the network. It is not initiated at a UE level. So there is no signaling that is sent across the interface. The MME, within the MME pool, there is a load balancing algorithm that's running that says, oh, this particular MME has too much load. Let's shift some of the UEs to some of the other MMEs within the pool, so we can balance the load between all the MMEs.
Weight factor.
Weight factor is it's an associated with some MME is an indication of the amount of load that they're carrying. So weight factors is proportional to the load.
So there's no signaling as being.
No, there's no signaling. This is something that's done within the pool. Okay, it's not done across the interface. Okay, normally remember in previous technologies, whenever you moved across a boundary, you need to send a whole bunch of signaling messages that go across the interface, and then they are processed, and so this is something that's done within the network. Let's just carry on. We've got again, as I said, I'm not planning to go into the details of each timing diagram, but a few things that we want to do is talk about idle mode. Remember, when we are in idle mode, the mobile is reachable, but no communication session is active. Okay, why do we have this idle mode? When a mobile has been idle, has not been transmitting any packets or not, the most important thing we want to do is we want to conserve the battery power of the mobile. We don't want the mobile sending unnecessary messages and wasting its battery power when it's idle. So the way it works is that the E node B is the one that detects that UE inactivity. Okay, so E node B has got certain timers in it, and it says, okay, a timer has expired, UE has not sent any packets, so UE is inactive. So in that case, let's try and move the mobile to idle mode. So that's a step 1 procedure, and step 1, idle mode is triggered by the E node B that detects UE inactivity. In step 2, the terminal location is now known on a tracking area basis, because remember, when we were transmitting packets, your location is known at cell level, but as soon as you are inactive, you're not transmitting any packet, your location is known on a tracking area basis. Just very similar to what happens in GSM. Okay, when you're making a call, you're known at cell level. When you're not making a call, you're known at location area level. Now, when the UE goes idle, it needs to initially register its position to the MME, and the UE essentially updates its position to the new tracking area. So this is when it has moved from one tracking area to another. Now there are two ways that it does a tracking area update. Okay, we have something called a location area update. We do a location area update when we move across a location area boundary. So similarly, when UE moves across a tracking area boundary, you do a tracking area update, and you also do it on a periodic basis. Okay, so on a periodic basis, when a timer expires within a UE and you haven't done a tracking area update, you perform a tracking area update. The diagram on 64 tells you what happens when you move from an active to an idle state. Now when we do a tracking area update, two things can happen. One thing that could happen is when you move from one tracking area to another tracking area, you could have a change in MME. Okay, it's possible. Okay, just like in when you have sometimes when you move from one location area to another location area, you could have a change in MSC, VLR, or when you go from one routing area to another routing area in GPRS, you have a change in SGSM. So in that case, we need to update the new MME. Okay, so when the UE performs a cell reselection, it can detect that it has entered a new tracking area that is not in the list of tracking areas that it was registered with the network. In that case, the UE needs to perform a tracking area update to update its location, so it's able to receive paging messages. So in this case, the signaling on page 66 and 67, it says what happens when you have a traffic area update which involves change of MME but does not involve any change of SGW. Okay, we move on to 71. Okay, when we talk about service requests, when a UE is in idle mode, it can trigger a service request, or the other possibility, the other way that you can have a service request is when you have a network triggered service request. Okay, so either the UE can trigger a service request or the network can trigger a service request. But in both these situations, certain processes have to take place. So what sort of things do you think have to take place? Okay, to answer that question, you may have to look at the next set of diagrams. Okay, if you look on slide 72, 73, and 74, they tell you the sort of procedures that take place. Well, if you look at the situation where a UE triggers a service request, what is the first thing that takes place? RRC connection. Okay, you can't do anything when you're in idle states. You can't do anything until an RRC connection is set up. Okay, and you connect. Now below that you have optional authentication. So optional authentication comes next, and after the optional authentication, you have some bearers need to be set up. Okay, so you need to set up a radio bearer across the interface. You need to get an S1 bearer between the eNode B and the serving gateway, and you also need the S5 bearer has already been set up at that stage. Okay, and once you have this connection set up all the way to the P gateway, then essentially you are now ready to have that service. Now this is in the case of UE triggered. So the UE is saying, I want a data connection. The other possibility that can occur, and that's given on slide 74, is a network triggered service request. So in this case, the first thing at this point in time, when the mobile is in idle, we only know at which tracking area the mobile is located in. We don't know at cell level where a mobile is. So the first thing that we do is we need to page we need to page in every base station, in every tracking area, within the tracking area that the UE is located in every cell. We need to go and page. And when we get a response, we go back to all of the steps. So paging comes first. After paging, everything that we did in the previous UE triggered service request has to take place before that connection is set up. Now the last thing that I want to look at today is the detach procedure. So detach is the opposite of attach. When do you do a detach? A detach, by the way, is, so that's a UE initiated detach. Then the other possibility you can have is an MME initiated detach. Now that, and the third way that you can have detach is you can have a HSS initiated detach procedure. So I'll let you figure out what the HSS initiated detach procedure is. So again, either a detach can take place due to any of these three reasons. Okay, and what do we have to do in a detach? What do we do when a detach takes place? Well, the basic idea when you detach is all of the bearers that were set up during an attach process have to be removed, and the RRC connection has to be released. So those are the steps involved in that.